Alright, this is the video for finding rate of change for the power focus area linear and exponential functions. Today we're going to go over how to find the rate of change from a table, a graph, and 2 points. So we'll start out with the table. So we've dealt with linear functions before, and we know you have a constant rate of change. So one way in the past we've looked at it is if we have a change in x, here's plus 1, plus 1, plus 1. That's a constant change in the x's. Over here we have plus 3, plus 3, plus 3. That's a constant change in the y's. So our rate of change is the change in y over the change in x. So in this case, every time the change in y was positive 3, the change in x was positive 1. So our rate of change is 3 over 1. Which is equivalent to 3 if we don't want to write it as a fraction. We go to the second table. Here we don't have a constant change. We went plus 2, plus 3, plus 5. But because we've been told this is a linear function, we can still find the rate of change. We'll just look at each one individually. So here we were plus 2 in the x's, plus 2 in the y's. So our change in y over change in x is 2 over 2, which simplifies to 1. If we were to look at the next 2 points, the change in x is plus 3, the change in y is plus 3. So we put the change in y is 3 over the change in x is 3. It still simplifies to 1. We could look here, change in x is plus 5. Change in x is change in y is plus 5. Change in y over change in x, 5 over 5 still reduces to 1. So our rate of change is 1. We don't have to have all the x's changing the same, y's changing the same. The key is when we find our slope, our rate of change, and we reduce it, it'll always be the same number because it's a linear function. The second case we're going to do is we're going to go look at a graph. So we can pick any 2 points, and we like to pick ones we have nice coordinates for. So here we have 0, 0, we have 2, 1, we have 4, 2. Those are all nice points because we have integers for the x and y coordinates. To find the rate of change, we can pick any 2 of the points and just calculate our slope by counting. So if I'm going to use the first 2 points, here the change in y is 1. The change in x is 2. So it's change in y over change in x. That's going to be 1 over 2, or 1/2. It doesn't matter which 2 points you pick. Your rate of change will be constant because it's a linear function. If we had started at the third point and gone back to the first, our change in y would be minus 2. Our change in x would be minus 4. So that's negative 2 over negative 4, but the 2 negatives cancel out when we simplify, and 2/4 reduces to 1/2. So we still get the same slope. It doesn't matter which points we pick or which order we go in. The third method we're going to look at is when we have 2 points. We're going to use the slope formula. Slope formula is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. The key is this needs to be the coordinates of one point. This needs to be the coordinates of the other point. You can't get them diagonal or you'll get the wrong slope. It doesn't matter which point you use as point 1 and which one is point 2. Here we've already labeled them, x1, y1, x2, y2. So we're going to just take these coordinates and plug them into our formula. So m equals y sub 2 is 2 minus y sub 1 is 1 over x sub 2 is 4 minus x sub 1 is 2. 2 minus 1 is 1. 4 minus 2 is 2. We have a rate of change or slope of 1/2. Doesn't reduce, so that's going to be our answer. In the second example, again, it doesn't matter which one's the first point, which one's the second. So just to do it different, I'll call this x sub 2, y sub 2. This will be x sub 1, y sub 1. Substitute into my formula. M equals y sub 2 is 6 minus y sub 1 is 0. over x sub 2 is negative 3, minus x sub 1 is negative 1. 6 minus 0 is 6. Minus a negative becomes adding. Negative 3 plus 1 is negative 2. This could reduce to 3 over negative 1 or just negative 3 if I'm not worried about having a fraction. So my slope is negative 3.